Here's an example of solving simultaneous equations using the substitution method. The reason why I'm going to choose the substitution method is both of these equations are set equal to y. Because they are both set equal to y, that means that these two pieces over here are equal to each other. Essentially, I'm going to take the 3x minus 5 and substitute it in for this y value here. So I get the equation 3x minus 5 equals 2x. Now there are several ways you could go about solving this. I prefer to use as few steps as possible, so I'm going to subtract 3x from both sides. When I do that, these cancel out, and notice that the negative has to come down on the 5. So I get negative 5 equals negative 1x. To get the x totally alone, I need to divide both sides by negative 1, and therefore the value of x is 5. Now I need to decide, which of these two equations do I want to plug that into? The second one is shorter, so I'm just going to plug in a 5 right here. What does it mean again when things are side by side? That's right, we're going to multiply. So we need to do the problem y equals 2 times 5. Therefore, y is 10. Finally, as a coordinate pair, our solution is 5, 10. Here's another example of solving simultaneous equations. I'm going to use the substitution method. The reason why I'm choosing the substitution method is if you notice in this first equation, my x is already alone. That means I can take the 3y minus 2, substitute it in for x in the second equation. I'll show that in red. So I took the 3y minus 2 and filled it in for the x. So it'll be 2 times the quantity 3y minus 2 minus 4y equals 0. Perform the distributive property, and I get 6y minus 4. Bring down the minus 4y equals 0. Collect my like terms. 6y minus 4y leaves 2y, so I have 2y minus 4 equals 0. Now it's a nice two-step equation. First, add 4 to both sides. So 2y is equal to 4. Now to get the y totally alone, divide both sides by 2. Therefore, y equals 2. Now, with the y equals 2, I need to look at my two original equations and decide which of the equations I want to plug that value into. I think the first one will be easiest, so I'm simply going to substitute in a 2 here for the y. That becomes the equation x equals 3 times 2 minus 2. 3 times 2 is 6. 6 minus 2 is 4. So as a coordinate pair, the solution is